Now we're going to move into our last unit, where we're going to start in chapter 11 with counting and probabilities. We're going to be looking at some more advanced, as it were, ways to count the different number of ways that a given set of things can occur, as well as how likely it is that some specific arrangement is what occurs. And to start, we'll think of a pretty basic example where, think about, say, you get up in the morning and you're about halfway through your laundry cycle. So you've got 2 pairs of pants left that you want to pick from and 3 shirts. Now, presumably, you're just going to be wearing 1 pair of pants and 1 shirt specifically, because, this is Florida. We don't necessarily need to layer up too much. And also, you're presumably going to be wearing just 1 of each. I'm guessing most of you aren't nudists, not to my knowledge anyway. Not that I would judge, but, for the sake of statistics, we're going to assume that you got 1 of each. And also, we're kind of throwing a bit of fashion out of the window. We're just going to make all of our different options that we can without consideration of whether or not they actually look good. We're doing math. We're not thinking about style at the moment, although it'd be nice if those two things did overlap more often. Anyway, for this, we can think about separating our options in terms of what type of pants we wear, and then what our options are for shirts on top of it, with something like this tree diagram that we're looking at right here, where we could select 1 pair of pants, and then from that 1 pair, we have 3 shirts to go with it. And then with the other pair of pants, we have the same set of 3 shirts that we could pick from, but the long and short of it is, we get 6 total options. Now, something like this diagram that we have here is always an option we can fall back on for being able to count out all of our possibilities, but it's a bit time consuming even with just 6 options here. So in general, what we can do is think of a pattern to work with for this type of problem, where we say that if we want to get the total number of ways that we can arrange objects, where for one we have m unique options, and for the other we have n unique options, then the total number we get is just their product. M times n unique options. So here we had 2 pairs of pants, 3 shirts, multiply that together, and same as we got from counting, you have 6 options. So let's take a shot at another example for this type of problem, where here, let's say that you're going out for lunch, and you go to Chick-fil-A, and you also want to get a snack from the vending machine. If there's 4 things on the Chick-fil-A menu you like, and 16 things you might want from the vending machine, where you've only got enough money for 1 of each, and you're definitely getting 1 of each, and you're not really thinking about whether, the sandwich really would go well with that honey bun or not, but you're just picking. How many ways can you make a meal from 1 thing on the Chick-fil-A menu and 1 thing from the vending machine? So here for this example, you will end up having 4 options from Chick-fil-A and 16 from the vending machine. So 4 unique there, 16 unique from the second. You just multiply them together to get 64 total options. And this is the type of process you can see with just about anything, where all you're taking is a selection of 2 unique things, or 2 categories of things that you must get both.